Ladies and gentlemen, welcome to this seminar on Ecodesign and Innovation. Most welcome. I am Agneta Persson and I work as a consultant at WSP and I'm the Vice President of eceee. The seminar is today organized by eceee with support from CLASP, the Swedish Energy Agency, and Energifonden. And we will be dividing this day in 5 parts. It says 3 if you look at the program, but it's actually 5 parts. The first part is an introduction. The second part is Ecodesign to boost innovation. The third part is innovation to boost ecodesign. And the question is, of course, is innovation driving the ecodesign or is ecodesign driving innovation? And I guess it's both, but we will hear about that today. The fourth part is a roundtable and discussion. And I hope you have a lot of questions for the discussion, that it really spurs a good discussion today. And the final part, when we can ask all the questions we didn't have time to ask during the day, and we've been walking around wondering about for a long time, is during the mingle and cocktail in the evening. So once again, most welcome to this seminar. And we will be having an introduction by Mr. Niels Borg, who is the director of eceee, and Mr. Peter Bennick from the Swedish Energy Agency.
Thank you, Agneta. And welcome everybody. I don't know, a lot of you are in a way new to eceee, and we're very happy about this. Anne, my assistant in the secretariat, well, she wasn't complaining, but she said it takes a long time this time to register everybody for a seminar because there are so many people who are not in our database. So they're new to us, and this was a very, very, very nice thing to hear, because there were many, many of you that have not been in touch a lot with eceee before. So that's very good news, and we're very happy about that. As you know, eceee, we are an NGO. We see ourselves as an expert NGO with the sole aim to foster the understanding and the analysis and the knowledge of energy efficiency. And we always take pride in ourselves to say that we want to give advice and information based on evidence. And again, this is what we're trying to do today, to establish evidence-based information on ecodesign and efficiency. I don't think we will come to a conclusive answer today, but I really hope we will be able to advance this and to give us new tools and new understanding of ecodesign, and of course not only ecodesign per se, it's product policy in a broader sense, but we thought we would like a short and catchy title. And ecodesign, after all, is one of the, as we see, one of the major European policy instruments we have today that deliver the most, and therefore we thought it was very nice to focus on ecodesign. I will not spend more time here, so we will give our real speakers here today the time they deserve and need. So I will say again, thank you to Agneta, who takes on this very arduous task to chair this the whole day. Thank you very much to, again, I would say, to Swedish Energy Agency, who took the initiative to this and asked eceee if we wanted to work and host this seminar, and of course to, I would say, hello to our absent friend Pernille Schilrup from CLASP Europe, who couldn't be here today because they're all on a retreat, but who has also been very, very instrumental in supporting the seminar. And also Energifonden from Denmark, who will help us with some of the funding, so we can afford to film all this, and it will be published on our website in due course. You can all go back and see all the goodies once more. I hope you will enjoy the day, and I will now ask Peter to speak a bit on why we are here. Thank you very much.
So good morning, everyone. I'm not either one of the one of the real speakers either, but I just would like to say some words about why we think this is important. And I think you probably agree with me. So innovation is important for government, that is for sure. And I will come back a little bit to why in a slide in a moment. But what is really important for us as well is we put in a lot of regulations within the EU, outside the EU, etc. And now we get the questions, do they actually deliver or not? And we say, of course they do. And they say, our governmental ministers say, okay, prove that. So we need methods to actually prove that the regulations delivers. So today we'll discuss some of the methods or some new methods as well that can show that. But also very important is to see, can we use this method to actually tweak the regulations to get more out of the regulations, to force innovation to go faster. So today we will discuss this a lot, I hope, and it's really a discussion. We need some feedback from you as well. You have a lot of experience, so please give your feedback. That's very valuable. And I just continue with some. I was, well, thinking myself, things are improving, of course, but from a personal point of view, I don't think it's really going fast enough. Well, you have seen this picture many times before, I'm sure about that. But what I think is really interesting to say, we need some person or some leadership saying that we want to go that direction. And today, I think we are lacking that. I shouldn't hang out the Commission or anyone else in the world, but we need someone actually saying we should go this way. And you know, 1961, Kennedy said we should go to the moon and bring a person back safely. Not just put him there, should also go return. And at that time, you can understand what was the LCA about that, the life cycle cost assessment. Was it sort of, would it pay off? Would it be worth it? Well, I read a little bit, and the initial cost estimate was terrible, I can say. So I just checked a little bit more. How many people were involved? Yeah, there was tremendous lot of people. From NASA, it was like 36,000 people. But more important, industry, private companies, institutions, they were also involved. So this was an enormous boost for American industry and enterprise. And yes, the cost was very, very high. And maybe you know there's a guy named James Webb. He was the second administrator of NASA, and he had to fight a lot in the political corridors in Washington to again and again persuade the politicians to really go through this. And he also pointed out that already in 1961, the technology was there. They could have done it already in 1961. But this was really a matter of management. To get all these people together, agree on the goal, and then go there. So he said that the greatest achievement with all this exercise was really to do the management. To get 400,000 people together and send that man to the moon and get him back. I think we can learn something from that. And then, yeah, was it worth it or not? Well, from a cultural point of view, yes, it was really worth it, because this was the first time you could really see these pictures from the moon on the Earth. Gave a very profound insight about the planet we are living on. And then, as you know, there was a great technological impact, material science, all these fields developed very fast and boosted the whole American economy, and they probably gained from that still, I don't know. And there were sure early estimates about the cost and the return on investment, and yes, it paid off very highly even. So today, what should we do? What is our goal? Just to bring sort of the high, my job is to sort of have this hallelujah speech. So, is it climate change? Yes, it is climate change, but it's actually more than that. And I don't know if you have seen this Nature article came in, what was it, a couple of years ago? A lot of researchers going through not just climate change, but water resources, phosphorus, nitrogen cycle, etc., and said that there are some boundaries we cannot really exceed, because then the planet will be in trouble. And they are connected together. So climate change is one of them. And you can see this is sort of a measure of how bad it is. And climate change is here. We haven't sort of reached the boundary yet. But there are other things here. Biodiversity, for example. We are killing a lot of species every day for the moment. And you have nitrogen cycle here. So some state of the planet is not very good right now. So we need innovation. We do need to do something. And today we're going to discuss how. So by that, we'd like to turn over to the real speakers who are going to tell you how we will do this. Thank you.
Thank you very much, Peter and Nils, for this introduction and setting it into its frame, what we are going to discuss today. And we all know that it's important with innovation, and we all know that we need to find ways to deploy new innovations, and that's what we're going to talk about. And before I hand the floor over to Hans Nilsson to talk about When You Wish Upon a Star, Innovation on Demand, an introduction to the dynamics of innovation.
Okay, thank you, Agneta. Peter was asking for a leader for this game, and I'm proud to say I've found him. It's a cricket from Pinocchio. But the issue now should be to see where we can find innovations. Do we just wish for them? Could we demand them, or do they just happen? Is it like in Forrest Gump, that life is like a box of chocolates, you never know what you get? We see. Now I was instructed to do like this. Okay, this works. I would say that the key issues are the companies and the company perspective on change in society and in a competitive environment. The dynamics of innovation, we will turn to Joseph Schumpeter first and say what he said about it. He said that economic change revolves around innovation. It's entrepreneurial activities that is a market power, and innovation-originated market power gives much better result than the invisible hand of the price competition. So I think that first of all tells us that a very traditional view is that things are just happening slowly in the society, price have all the information, and things, you just relax, sit back, nothing, you can't do anything. He also said that technological innovation creates temporary monopolies, which could also create rather big profits. Even he said that they were abnormal profits, but they would be competed away by rivals, and those profits could be necessary for the innovation process. So I think that is also an important message for us. When we are looking around us, we very often fall into a trap discussing about whether the profits are too high or too low or enough. But Schumpeter said this is a normal process, and I will give you examples of it later on. Schumpeter also pointed out that there were 5 different types of innovations. A product innovation first, which is what we normally think about and talk about. We need to see new products with different performance characteristics. The process innovations that are sometimes necessary for the product, the business models, the source of supply, and mergers and divestments. And I would like to point out that even if we are primarily interested in the product and what happens with the product, the business models are very important for us. If we, for instance, look at the latest energy efficiency directive, there's a deliberate attempt to change the business models by giving energy service obligations to energy companies. A total change of the business model that could be an innovation in itself and could foster new innovations. And finally, that organizations of the companies could also be part of the innovation game. Which companies do cooperate, and why do they cooperate in order to make the new business models work? So innovations, I would like to say, on maybe summarize this part, is a social game with a societal impact. We need new combinations of existing knowledge, resources, and equipment. It's a specific social activity with a commercial purpose. But we also have to distinguish this from invention, that is a different animal. There are inventors all over the world who are inventing, and that might be a very good thing for us, but they do it without the intent of commercialization. And sometimes in the political debate, we start to confuse things, and politicians try to come up with policies which might be very good to create more inventions, but not necessarily innovations. What we would like to see for energy efficiency from the innovations is better performance, you should be able to do more, lower cost, do more with less, and to outperform wasteful supply. So now I have tried to at least give some, should we call it some issues or some benchmarks of what we should look at when we are trying to discuss innovations. And if we want to make a model of innovations, it could look like this. And I'm using this only to confuse you. But my point is to say there's a whole lot of issues when we want to change and when we want to push innovations. But we should try to, with simpler models to begin with. It could be a chain. This is from the IEA Energy Technology Perspectives, the latest issue, where they're trying to say that innovations, there is an innovation chain, they say, where research from academia finally results in demand and benefits consumers, governments, experts, and so on. But luckily enough, they also put in a feedback chain in here. So it's not a chain, but it's a recursing chain. So it would be easier to say that innovations happens in a circle, where you have two policy aspects. One is the R&D. If you pour more R&D, more money, more brain power into technology development, it would improve technology. And this technology development and R&D happens both in academia and in the companies. And deployment is the other handle you have on the policy mechanism, which will result in lower cost, which will result in accumulated volume, and in experience going back to R&D. And I think this is quite useful to think about innovations as happening as something that goes on and on and on, and that is actually what we see in the learning curve. So we will turn to them and see what the learning curve tells us. The learning curve pictures the star falls, and I deliberately call it the star fall because the learning curve is always sloping down. You sometimes hear people say that they are moving up the learning curve. They can't do that because the learning curve is showing how costs are decreasing by an accumulated volume on the market. And you could roughly say that the price of the cost is reduced by some 15–25% by each doubling of the cumulative volume. And the new technology, the challenging technology, might reach a break even at some point and be competitive in its own right, price competitive to the old technology. I feel very awkward looking like that, but I hope that you can forgive me. This is the only way. If you look at market dynamics, you will also see that what we can observe is the price, not the cost, what we see from the outside. And this is what Schumpeter talked about when he said that innovations could create abnormal profits for some time. The first mover on the market had a good position to recover the cost for the development, and this is a price umbrella. And I will just raise my voice. If you have the actual learning curve like this, what you can observe is the price, and you may see the price umbrella, but at some point you will also see a shakedown, so you will return to the learning curve. That is when the competing companies, those who comes after the first mover, catches up. So the market attracts more producers and stability will be eventually achieved. This has been, these first theories were developed, I think, was by the Boston Consulting Group, so it has been shown over and over again that this happens in reality. Learning curve and refrigerators. There's a quite interesting article, you may have seen it, several of you, from Energy Policy 2 years ago, now 3 years ago, by Martin Weiss and his fellows, analyzing price and efficiency dynamics of large appliances in energy policy. And I will highly recommend it because it gives you a lot of insight in what actually happens on the market. If you look on the price of refrigerators, which these guys have tried to do over a quite long period, 1964 to 2008, they find a learning rate of 9%. You may remember I said 15 to 25%. This is the price impact of the innovation during this period. But if you look on the performance impact, you will see a slightly different picture. You will see a learning rate of 16%, meaning that performance of these refrigerators have improved by each doubling of the market by 16%. But the most important thing you will see is in the later years, they have tested from 95 to 2008 and found 49%. And they say this is an impact of energy efficiency policies. So that is why I highly recommend this article for studying, and also as a sort of a background to this workshop, what sort of energy policies can make things like this happen? Could it happen in other areas, or is it just refrigerators, etc., etc.? There are a lot of questions, but I think it's encouraging to see these numbers. So that is what, how should I say, what we could find out from looking on research. If we look on the deployment methods, we have all seen these curves over and over again, how you are trying to change the performance from the base case, the blue case, to the purple case, the preferred case, where energy efficiency performance improves over the time. And you can do it by standards and directives, by, for instance, aggregated procurement and technology procurement, and several other methods as well. But you need to try to move the curves in more than one aspect. Otherwise, you will end up with a skewed curve like this, which you also may remember that you have seen in the Ecodesign studies. And maybe you will see more of it soon. My point is just to say that, yes, there are many instruments that need to be used, and the deployment is a very important part of the innovation, that if you really want innovation to take up speed, you must also work with the deployment issues. We will look on a real case, and I happened to find a real case from Electrolux. They made a presentation some 10 years ago when roughly the same issues as we are discussing here today were on the table. And they showed how they're in their own internal thinking about what sort of products they should put on the market, what sort of products for which there will be a demand in the future, what will their role in that. From a latent, what they call the latent consumer demand, to a market growth. And they made, as all companies, internal studies, which they call visions, policy studies, and they came up with a strategy. And that strategy then guided their development, the market deployment. And if you see on the lower line, you will see where society comes in, where the administration comes in, because they were expecting, it has already been announced at that time, that there will be a product labeling, there will be energy limits legislation, and so on. So they were trying, on the backdrop of what they expected of societal initiatives, to come up with what sort of products should they have and what were their role. And their role, they said, was to be the leader, because this is what they thought about. And this is not a learning curve, this is a normal time curve of costs. That if the costs could drop, and that is, of course, there is a learning behind it, the price that they could expect, they come up with an idea, and the total sales. And they also trying to find out what would the market followers, their competitors, do. And if this happened, as they portrayed in these curves, they will have a shareholder value that could be quite big, from being the leader, the first mover on the market. And they could see that the followers' shareholder value would also be reaped, but it would be smaller. So the point is that they had an idea that this shareholder value should be an enabler for their reinvestment. And they also tried to picture what role did performance standards, a mandatory declaration on products, minimum efficiency requirements have in growing the consumer demand for the new products. And they hoped for, and of course worked for, and lobbied for, that there should be subsidies for these products and that there should be procurement programs for deployment of the goods. So I think this is an interesting inside look on big companies, and I know that there are several other big companies, and I've heard from their staff, people who are in this room actually, who have internally exactly the same sort of discussions. Do they want to be the leader? Do they want to be the follower? And if, when should they start to move? So, trying to boil this down as a sort of a guide to the galaxy when we are looking for the stars, I tried to put down some buzzwords for policymakers. First of all, challenge. Try to challenge. Try to go for a step change, not only incremental, and do it in a pace. If companies could get a signal, a message like the one we saw that Electrolux picked up, that aha, there will be a labeling program, aha, there will be technology procurement, aha, there will be something else, they could try to find how they will fit in and how they should direct their research and development into a product that serves the market. Try to have confidence and build confidence that the market will build and that the investments will pay off. Maybe we will need the Kennedy of energy efficiency. I don't know who he or she is, but it would be nice to have a statement of the same sort. Travel into the refrigerator and come back. Persistence is very important. Try to use roadmaps and show progression for performance. The companies who we hope should put the innovations to the market, make it happen, they need to know that, yes, it will happen. It will not go away. It's not a whim of the day, which is quite often so when we look at, on energy and energy efficiency policies in the countries. Make sure that there is a volume big enough to compete for. My own experience said that sometimes when you are starting the process, the volume does not have to be that big to make it happen, because many companies who are innovators, want to be leaders, they are happy to test an idea, but it will be a total dead end unless there is a volume big enough to compete for. And in today's society, it might be that the volume we are looking for are not only national, but they are regional and they are even global. We must know that there is a capacity and an ability to develop within the industry, within the branch of industry and within the specific companies. The knowledge is already there. Very often it's not revealed to us outside the companies what the companies actually think they can do. But there's gossips and there are rumors, and we could pick that up. And then, of course, there should be incentives. Not necessarily in monetary value only, but incentive that makes it pay. And for instance, if we again look at the Electrolux perspective of being the leader, yes, of course, it was money in the end, but to get to the money, it was important to be known to be the leader. It was the marketing aspect of being a leader that was important for them. So if we should look a little bit on who should participate in the game, first of all, we need a market framework, and that is what the administration and the government provides. Secondly, there must be an industrial capacity, and that is basically the research and development, the innovation that happens in the industry that we are aiming for. And then there should be a customer, consumer, market uptake. But my point with this is to say that we need all three of them, and we cannot exactly say in the beginning who is starting the game, not even who is going to carry it through all the way. But I would like to say that we have, and I've been involved in the work in the IEA where we wrote a book called Creating Markets for Energy Technologies, where we quite easily could find that in the most successful programs, all these three components were involved. And we found a quite, at least in my mind, amusing example of that, and that was from Paris way back in, I forgot exactly when it was, where there was a decree that you were not allowed to throw garbage on the streets anymore. And there have been many decrees over the years about that in Paris, and still people threw garbage on the street. But then the prefect of Paris in those days, or the governor, he also invented a garbage can, so people could put the garbage in something, which was quite a good idea. So he, from the market framework that he created, he also made the industry produce a garbage can. Actually, the garbage can had exactly the same look as in many of the computers, maybe not anymore, but in many of the computers you had exactly this corrugated garbage can. Then there was a sort of an uproar from some of the people in Paris who earned their living from selecting from the garbage things that could be washed and resold. So they were trying to topple over, but after some negotiations they came in line. So all these three parts were involved. The decree created the market framework, the industry produced the garbage can, and people and the interested stakeholders, they were settled finally, all the three parties. And the name of the governor was Eugène Poubelle. So that really shows, for those of you who speak French, poubelle is a name for a garbage can in French, that if you are coming up with something, you may be remembered forever, a garbage can, for instance. Well, that's all. Thank you for listening.
Thank you very much, Hans. As always, a very interesting speech. I was thinking of some questions to you myself, and I hope the audience have one or two quick questions already now, and then we keep the others. But I was thinking of a temporary monopolies you mentioned. And as I've been working a lot myself with technology procurement, I've been pondering on how can we make the temporary monopolies attractive enough, because that's one of the major issues. And in that essence, I also wanted to ask you about trust and self-esteem, because that's an important factor for the companies who are developing new products or innovating new products. So could you elaborate a little bit on that?
Yeah, but that is partly why I said my experience is primarily from technology procurement, just as the one you referred to. It was astonishing to me to see that the volumes that the companies were competing for were not very big. So there was not very much money involved in that part of it. Of course, and I remember one of the discussions we had right after the company had won the technology procurement, they had put the new product on the market, and then they priced it. And we looked on the price, they said, and we being government officials didn't know much about market. We were scared to death and said, you are going to price this idea out of the market before it even happens. And they said, no, it will not. And it went a year or two, and then the followers came up with a similar product, and the winner dropped their price. So they were exactly using the price umbrella that, and the idea that Schumpeter has talked about. My point is rather that I think that it was the self-esteem and the marketing value for the companies to be known that they have won the technology procurement. They were the first. They could use this in advertising. And probably to tease their competitors as well and say, haha, we did it, you did not. So to me that was a sort of really an astonishing experience to see that we did not have to bring all these big chunks of volume, because the businessmen who were participating in the game, they know that it was a game, and they knew that it could happen, but they also knew it might not happen. But so that is partly what I like to think about of this as a game. It's nothing that we can guarantee that it will happen, but it's a good attempt.
but with a quite thick layer of trust in the bottom of this game.
Oh yes, because again, if we go back to say the consumer, the demand that we tried to recruit for the technology procurement, they were again companies that the supplier thought that if this company is going to buy this product, well, then we are home, because this company is a trendsetter or whatever they thought of them. But that is part of the fun, because being a government official and just trying to hand out grants and things like that, that's not very fun. This is much more fun.
Okay, anyone in the audience with a question for Hans at this stage? Please state your name and where you come from.
Jan Storm. I'm with the University of Maastricht in Holland, and I work on science and policy from a policy background. I have a question and a remark about the challenge for policymakers, and I refer to Peter's contribution when he said it doesn't stop at climate change, it's about the planetary boundaries issues. When we look at those issues, they are complex and interdependent according to the analysis. And that means that in terms of risk and uncertainty, it is a totally different ballgame than a linear risk model. And I see as an obvious conclusion, I'm not a scientist, but that's my gut feeling, that there should be a much more precautionary approach to policy making, meaning you have to be much more ambitious to avoid risks to the maximum extent possible, at acknowledging the uncertainties. And given the scope of the risks, I think the challenge to be articulated towards policymakers should really be at the forefront and could be reinforced by this analysis. And then it could have the potential, with the optimal policy design integrated and what have you, to drive innovation much more forcefully. I just wanted to share this observation with you. Thank you.
Thank you.
I would be happy to agree to that and add it to the list, but that is also partly why I said that the challenge should look for a step change, not only incremental things that might happen next week anyway. And unfortunately, many policymakers are too coward to do that. But I'm happy to agree with you.
Thank you. So now from wishing on the stars to technology forcing standards for product efficiency and innovation. And Mr. Kevin Lane from Oxford in UK.
Thank you very much, Agneta, for the introduction. What I'd like to talk briefly about is something called technology forcing standards and how that might relate to products and innovation of products. It falls out of a very small piece of work that we did for the IEA 4E implementing agreement. So that was a report produced last year, and I'd just like to run you through some of the findings we found in that. Okay. Oh. Okay, you see something different to me. Right, so what I'd like to cover is basically just give you a very brief background of the study that we did, try to give you some sort of definition of what I think a technology forcing standard is, maybe give you a more softer word for that as well, take you through some examples in the literature, then run you through some of the pros and cons of trying to go after a true technology forcing standard. A couple of examples, and then leave you with some thoughts, maybe some pragmatic ones on how we could use it within our current eco-design framework. Okay, this is the project that I'm talking about. It was funded by the IEA, and basically we're trying to look at past experience of technology forcing standards. So these were in other areas, not appliances, but in other areas like cars, environmental regulation and the like. I'll take you through some of those examples, and then ultimately we're trying to see how that could be applied to appliances and what the issues were if we were trying to do that. My co-author Fiona is in here somewhere, over there. Thank you. And the report itself is available on the IEA 4E website, which you can download for free. Okay, so what is a technology forcing standard? Essentially, it's a legal requirement to bring forward a technology that's currently not on the market or commercialized or currently considered too expensive to be brought to the market. So this requirement will bring something that's beyond what's currently available, so it really should be driving some sort of innovation and I'll give you a better definition in a moment. The classic example that people give is the Clean Air Act of 1970 in the US, where there's some very strong regulation in 1970 that was introduced to try reduce car emissions within 5 years to a very low level, to try reduce particulate emissions in particular. At that point, there was no technology that was known how to do it, but they managed to do that within a few years, and it led to the catalytic converter that was successfully introduced, well, successfully more or less within 5 to 10 years. That's then compared with another approach of trying to introduce innovation into the market, and the example that's given, Gerard and Leif have done a very nice policy analysis of this to compare these two different regulations. One where it's a very strict regulation, very strong technology forcing regulation, versus another less stringent regulation or less requirement, and that was to introduce airbags. It was about the same time, it was the same sort of technology development involved, the same sort of costs, and yet one happened very quickly and one took maybe 20 years to happen in a more voluntary nature. So this is their classic example, just comparing and contrasting different policy approaches. If you're interested in policy, this is a nice analysis to go and have a look at. The report that we did, we looked at a lot of other regulations as well. There's a list there. You can go into the report to see which ones we did examine and see what lessons we could learn from the different regulations and draw some conclusions for appliances as well. We also looked at some of the appliances regulations that were essentially technology forcing but not quite there. So ultimately ended up with a definition for technology forcing standards. It was something like this. Basically the performance levels meant that the products shouldn't be on the market at the moment. They were too costly or perceived to be too costly to put onto the market. We essentially required some form of innovation to bring them to the market and then ultimately some broad diffusion. And the main thing was it was had to be driven by regulation if it was a technology forcing standard. Okay. You might be asking, so where would such a regulation sit at the moment amongst all our other raft of regulations and policy measures that we have in the EU and the member states and around the world? Most of you should be familiar with this sort of curve at the moment. On the x-axis along the bottom, you're seeing the efficiency going from least efficient on the left to most efficient on the right, and then on the y-axis just the number of products on the market. Usually we have a mix of policies that are trying to pull our curve towards the right. And we have some softer ones like endorsement, procurement, which you've heard about, which are trying to pull those policies to the right. We have the Commission at a European level, we have minimum energy performance standards, MEPs, labels, all trying to help the market move in that sort of direction. If we're looking at technology forcing standards, we're actually saying, well, can we go further and how far can we go? It should be beyond the best available technology or max tech or best not yet available technology. It's that sort of area where we're trying to push the standards, try to move our products towards. Okay, so some pros and cons of technology forcing standards. Well, the clear, obvious pros, if you can set this requirement sufficiently well, it gives should give a clear signal to the supply chain to where it should be going. If they have this clear message of where the market should be going and the time frame, it should mean optimal solutions for the industry to try and implement that. They shouldn't be chopping and changing and having different approaches. The main pro is that if you do set these standards sufficiently well, there's almost a requirement that the industry has to innovate, so you're almost forcing industry to innovate in some way. Of course, there's some risk with that if you're going with such a high level of ambition. The main risks are going to be that the industry may not try to do that. They may fall short if you haven't set the target very well. The regulator risks some loss of credibility if they do get it wrong, and that's quite a serious one, so it takes a bold regulator who's going to go down this route. You may end up with some products being lost from the market. Perhaps a main one, if you are going to force industry to innovate, they will need some sort of access to capital to do that. So some smaller firms may have issues with that, so you may need to provide some support mechanisms to mitigate that. And there's a few other ones as well that you can check in the report. So skip. At the moment, we do have some technology forcing standards that, well, we have some regulations that appear very similar to technology forcing standards, and in the EU and the US we have minimum energy performance standards which go some way to meeting those requirements. The basis for doing these are usually done on determining the performance levels, are done on an engineering analysis, and I'll explain a bit of that in a moment, but usually they're based on what we know on the market today or very near term on the market. And looking at some ex post evaluations of those, we tend to see that we overestimate the cost when we look back and potentially underestimate the potential of where we could have been. So these regulations, well, certainly in Europe at the moment, I think they're more to help with the diffusion of technology rather than really innovating or providing significant innovation in terms of where the market could be. There's Top Runner as well, which I won't mention, which is another TFS-like policy measure. Okay, that said, I would say that, yeah, Ecodesign and MEPS have been quite successful in moving the market. I would say that we have seen some changes in the market, but the question I'll be left with is how much more stringent could those MEPS be made, and how much more innovation could you introduce into that? There might then be questions of how desirable is that, and then also how would you ultimately go about doing that? And I'll try and answer at least one of those. If you're going to have technology forcing standards for appliances, I think there's a couple of things you should start to consider. One is that you should be looking really at the service that the products are providing, not being too focused on specific technologies. That gives a better way for the supply chain to deliver those. You do have different options of either not being at product level. You could have different levels of making the supply chain conform, whether that's company level or other ways. If you're having technology forcing standards, you may need to have a longer time period as well to allow for innovation to happen and those products to diffuse in a better way. There will be some issues to do with metrics as well, and developing good indicators and test procedures are really quite important to make sure that that happens. I think we've probably started to develop them already for some of the appliances for MEPS already, but others, I don't know, heating, there may still be some issues that having full load for a boiler is not really very helpful for making your heating systems more efficient overall. So sometimes innovation can be stifled by the test procedures itself, so there's an element of that that needs to be taken account of. I was going to show you a couple of examples, but only very briefly. The report has a few others as well, just to show where we could be going. I was going to show televisions, but I understand we don't have a talk later on televisions, so I might spend a bit longer on TVs. This is a chart from a piece of work that DEFRA did just over a year ago, and it was trying to project where they thought technology would be in the future. So it had different technology types, so from LCD and LED backlighting through to OLEDs, and then even quantum dots towards coming in maybe 2020 onwards, so in new technology in the future. But if you look where our eco-design limits that were set just only just a year or so before this was introduced, you see that the eco-design actually missed this by a long way. So this is, I guess, a question for us is how do we set our MEPs so that they could actually have caught that up? But another level, maybe we shouldn't be too worried if the market's going quicker, then is that really an issue? So this is a maybe not too bad a problem. Yeah, I think I've said all of that, and that's probably enough. So there's an interesting question. How would you make our MEPs for televisions? How could they have been done better to make sure that they could have been, well, keep up to date with technology? And maybe some people in the audience would actually answer that better than me. Lighting was the other one. Here we've got another technology where we've got a very good known technology going into the future. And then it's how should we be implementing or using this information to produce better regulations. So we've got some idea that there's a very large potential. Potentially, cost shouldn't be an issue if it's being developed well. The report itself goes on to examine lots of things, but it's mainly, there's couple of things with lighting which you need to understand. Luminaires, test procedures need to be done well. I'll just pick out one of the test procedures that maybe, or the efficiency metrics that maybe it doesn't have to do with lumens per watt overall. You could have other ones like watts per square meter if it's a service for a whole building, and perhaps that's already happening with some aspects of commercial lighting anyway. So there may be other ways that we should be looking at defining the service of the products or services. Okay, now more interesting ones. So some generic issues if you're trying to set standards, either MEPs or forcing standards or other ones. The main issues we have as a regulator is something called information asymmetry, that usually the regulator and the industry, they have a different level of information. The industry tends to know more and can push back. There's a few things that you can do to mitigate that. Yeah, you can use contracts to try and purchase that expertise. You can have panels, you can try to get feedback from the industry through stakeholder meetings, competition between regions perhaps, and also you can get inside information from component manufacturers or other aspects, or Hans Nielsen's friends who gossip to him tell him what's happening. The other important bit about this is political will. It takes a strong regulator to really push for strong MEPs, mainly because it's either going to be very difficult to prove how far you can go, if not impossible to go to a really far, a very tough level of ambition. So ways to mitigate that, and this is, I think, where me as a pragmatic level, where I think I end up getting to, is that really you either have to make your existing regulations work in a smarter way. You can either enhance them in some ways, which is either making your MEPs work better, or you have to use your other policy measures to make sure that your MEPs can work better in the future. Alternatively, you can throw everything out and start again and try have a much stronger regulatory framework, which I think that's a tougher route to go down. The other bit with having these technology forcing standards is a delay risk. You say there's a trade-off saying that yes, we can have these standards, but it will be a few years later, and that's also quite a risk as well. If you don't have that, you might end up with losing a few years worth of savings. Okay, so these are, as a pragmatic person, I think this is where I end up getting to, where you can end up with technology forcing standards. I think there's two main things that you can do is to make MEPs, or in our case Ecodesign, more stringent and more rigorous, and that will help you go further than we're currently doing at the moment. And then I'll use other supporting policy measures to try and help your MEPs process go further. Okay, so taking each, well, I'll explain both of those in a bit more detail. So the first one, if you look at minimum energy performance standards in the EU and also in the USA, the performance levels that we go to for these MEPs and Ecodesign should be based on these least life cycle cost curves. Most of you will have seen these, but this is the underlying basis of where we should be aiming towards for MEPs. So this curve on the x-axis, we've got high efficiency, high consumption on the left, low consumption on the right. So we're trying to go towards the right, towards the low consumption, high efficiency end. Up the y-axis is the life cycle cost of the product. So that's the purchase cost plus the running cost of the product. In this case, it's in pounds, but could be euros or any other currency. What we try to do is we have a reference case product, which is, say, £1,000 at the moment. We have design options, which are those dots. So it'll be more expensive to buy, but the lower running cost means that the life cycle cost should be reducing. At some point, we end up with a minimum down at 300 or so kilowatt hours per year, and that's a minimum or least life cycle cost. This is the point that regulators should be aiming for the MEPs, and that's what's spelled out in the Ecodesign Directive. Maybe not so clearly, but that's where we should be aiming towards. So my suggestion, or what was coming out of this, was actually we should be using this life cycle curve in a smarter way. So these costs that are integrated in there, these are static based on what we know at the moment, and we have got some options to say, well, what happens if these costs are falling? We've seen that Hans has showed some learning curves on what they could be doing, so we can push this further to the right if we take learning into account in these cost curves. In addition, we should also be asking ourselves, should it be going up to the equivalent life cycle cost? So to the consumers, they will be paying the same amount for their products, but we're making a bigger energy saving. So conceptually, maybe we should be going that little step further. And over time, that cost would fall as well anyway. And I think I've summarized that in that list there. The other bit that I would say was in this life cycle cost calculation, as well as taking this learning effect into account, you should probably think about including carbon costs, any air quality benefits, and other benefits you get within that calculation, so that the life cycle cost moves further to the right, that the target for MEPS is more stringent if we take that into account. At the moment, these learning carbon costs, they're not taken into account in these life cycle cost models, nor in our impact assessment models at the European level, although some of the member states do take that into account in their impact assessment models. So the UK, when it does its impact assessment, does take these into account and ends up with a very high net present value for the policy measure, which means that actually we should be having more stringent LCCs. My understanding is that the US also takes this into account into their impact assessment models and their national impact assessment models, and maybe even has started to do that in their curves. And I'll check with you later, Robert, which ones that's happening. The other recommendation to do is to try and remove some of the technology classifications. If you look at our MEPs, some of them are broken down into lots of different technology types, and that means that it's easier for some technologies to get a higher efficiency rating. So a side-by-side fridge is allowed to be less efficient than a top and bottom mounted fridge freezer. And there's lots of examples like that. Okay, so within our current eco-design regulations, I think we have got an opportunity to make them more rigorous and more effective and push them a little bit further. The other suggestion I was going to make is that we can use other policy measures to help make our MEPs down the line stronger. And the obvious ones are really things like identifying what the next technologies can be. We've seen procurement programs, competitions, prizes that can do that. But also we can have other policy measures to try and develop the market as well. So just standard market transformation things which will move the market. So we should be using those policies, rebates, endorsements, procurement, those other ones which at the moment are quite disparate and either within different parts of the European Union or in member states, and try to coordinate those better to try and push either the future forcing standards or MEPs further. Oh, so skip. So to leave time for questions, I thought I'll just summarise where we got to on this particular project. So technology forcing standards as they are, I think have got some potential to deliver further energy savings, clearly. But if you're going to do it, you really need a strong vision or clear vision of what the technology pathway is going to be like into the future. You can't just say we want to go there without having some understanding or belief that you can get there. The main benefit is that it shows a pathway or a roadmap of where you would like to get to, and that's already been mentioned. And by having this strong target, it also then demands innovation from industry to meet that particular target. However, it's quite a big risk to do that without, if you don't understand what's going on, it is a very big risk. You can set your targets at the wrong level, either in scope or scale, stringency, and if you get it wrong, you can lose credibility as a regulator and worse. So ultimately, at the moment, my pragmatic choice is I think we can actually make our existing eco-design directives more rigorous and more challenging, and also use other policy measures to try and support these eco-design measures. I think I'll stop at that point. Okay, thank you.
Thank you very much, Kevin. What I hear you say is that risk. There's a lot of risks for all the stakeholders involved. There's risk for the political leaders, there's risk for the developing industry, there's risk for the users, and we need to focus on avoiding or reducing those risks. That's my understanding of what you're telling us. And this technology forcing standards is one way of reducing the risks for the users and for the industry, I think. But how can we make the political leadership to take this on a much broader base? And how can we make them stop overestimate the costs and underestimate the impacts? So what's the main thing we need to focus on if we're going to reduce the risks? Or getting them to understand that this is the way to do the risk avoidance.
Yep, thank you, good. Yeah, so what I was explaining was the technology forcing standards as an approach. I think that is, as a conservative regulator, I think that's going too far. So my ultimate suggestion, or pragmatic suggestion in the end, was to use our existing frameworks and existing methodologies and make those more rigorous, and I think that eliminates more of the risk than choosing some arbitrary point, performance point down the line.
Yeah, sorry.
So I was going to say, yeah, so for the Ecodesign Directive, I think we have a methodology on where these points should be, but those aren't that clearly spelled out. If you look at the European version versus the US version, you'll see that the US version seems a lot more pinned down and rigorous in terms of determining just what is best available technology, best not yet available technology. Those seem more pinned down. And still to check to understand if I understand it correctly, they have got some ways of including learning curves within those targets as well.
And I was also thinking about the LCC, the life cycle costing, which is obviously what we want everybody to use, but there is always, in reality, a problem with the access to cash or capital. And how can we develop business models, and that brings back to what Hans was talking about, but we need to develop the business models as well. So is there anything that these policy measures you're talking about could help develop the business models for this, to increase the deployment of our better products? Did you get the question? You need to find what Hans was talking about as well, with the development of business models, and how can we support that with the evidence you are putting forward in your studies?
Good question.
Or maybe Hans would like to say something.
Well, I'm going to say, well, there's one bit is if we really are trying to make the industry to innovate, I think there is an issue that they do need some sort of capital to try and invest in that innovation. And yeah, maybe you do need to make that innovation capital available. I don't know if there are any, there are some European funds available for such innovation, which I'm not an expert on. I don't know if there are any experts on innovation funds in Europe.
Maybe we have someone in the audience who would like to take that.
I'm not an expert on innovation funds at all. Does someone want to talk to that point before I ask a question? Just building on that, about your question about building markets for products and linking into Kevin's discussion on technology forcing, I wanted to raise a concern that I have for eco-design, and actually in the non-directional lamps regulation. We have a requirement right now in Europe for B-class halogens to take effect in September 2016. And at the time that regulation was passed, at least one company, Philips, had a product on the market which was a B-class halogen. There were, I understand, some technical issues with that. It was withdrawn, and now there are at this time no B-class halogens. So I see that requirement in 2016 as being at risk, and I wondered what the panel's thoughts were on if anything can be done, because we have a technology force to support the market and to help bring those products so that we can maintain a B-class objective in 2016. Thank you.
Anyone who want to answer that, or are we going to get back to that later in the discussion, possibly? I think we'll get back to it later today. So, one more question before a short break.
Hi, Mia Forbes-Perry from the Policy Partners. Just on the sort of, I guess, subsidizing innovation, I'm definitely not an expert on subsidising innovation, but from what I'm aware of, the UK government at some point offered to subsidise some innovation in the TVs market, and essentially the funds that it could offer to industry seemed to industry to be so small that they wouldn't have been able to do anything. So I think it's a pretty difficult one from that perspective. And I had a question about if someone wanted to say something, Kevin, about if you pick a technology that's like in TVs, if you picked quantum dots or OLEDs, where some manufacturers are really way ahead of the curve, and most manufacturers are not even near there. So if you have like a 3-5 year time lag and you wipe everyone out of the market for that time, I'm just wondering if you could say something about that kind of scenario.
Yeah, that would clearly be an issue. Yeah, with the television curve, you actually saw that there was multiple technologies that were able to meet the Ecodesign directive, so even existing LCDs, LEDs would.
Sorry, I was thinking more beyond the Ecodesign directive, because that was not very challenging. I was thinking of in terms of technology forcing standards.
Yeah, in terms of technology forcing standards, that is a risk, and it is where do you draw that line so that you don't wipe out the market or don't remove an entire market, but actually challenge them enough so that they do raise that challenge and deliver the products, and also that there isn't just one technology that you end up giving a monopoly to one company as well. That could also be an issue that they will then have a price hold. And that's the risk with a real technology forcing standard, and why I probably in a pragmatic level wouldn't go down that way entirely.
And Hans had a comment. Was it on temporary monopolies, possibly?
Yeah, I think it was, because I really don't like the idea of subsidizing innovations. Innovation should come because the companies have the chance of an abnormal profit, in Schumpeter words, or risk that they will not be on the market tomorrow because all the competitors have run by them. So subsidizing innovations, no, I don't think so. That was my comment.
Okay, I think yeah, one final short remark then, and then we will have discussions this afternoon, so don't worry. Just write and take a note of your questions and we will come back to them. I'm sure we will come back to them.
Yes. Policymakers can make a difference by increasing mitigation targets for climate change. Carbon price will go way up, good for innovation. And they could eliminate environmentally harmful subsidies on, for instance, fossil fuel related energy. Makes a big difference as well. It should be on the agenda.
Hello, Evelyn Derieux from the LIFE program. In terms of supporting innovation and financing innovation, EU provides funding, as you know, they are complementary. So they can contribute. Just to remind, of course, the research framework program, but then you have the LIFE program, which helps supporting the development phase and the demonstration phase, and at pilot phase also. And then you have the support with the innovation program for coming to the market. So that's part of a contribution to supporting innovation at EU level. Thank you.
Okay. And yes, you had...
To respectfully disagree with Mia on that point about innovation. The two quick examples from the US, I think it has to do perhaps with the government's political will and whether there is a domestic industry that stands to benefit from the spending of public funds in that way. And in the US, we've had a multi-million-dollar annual research program into solid-state lighting, which I was involved with for 10 years. Fantastic program. It's built up a tremendous industry. They've had competitive solicitations on an ongoing basis. It's now about a $50 or $60 million program that's running. And it's not just the US, Japan, South Korea, China, they're all doing it because they're trying to nurture the next generation technologies in their economies. But a practical example of something which came up, Robert and I have a friend in the US who works at the Department of Energy, Tony Buza, who is working on R&D investment and innovations. And we have, as you know, heat pump water heaters, and a lot of homes in the US have electric hot water heaters, and they tend to be resistive heated, and they're about $300 or $400 a unit. Tony's innovation was to put out a competitive, and you can buy a heat pump water heater now, right? But they're all over $1,000 a piece, so it's more than twice the price. So Tony's innovation was to put out a competitive solicitation to develop a electric water heater that has a coefficient of performance of 1.1. So it's just more than you can achieve with resistive heating. It has to be heat pump technology or something similar. And to win that award, you had to have it at a sales price of $500. And they put it out there, it's a multi-million-dollar award, and he's had 2 companies apply, and they're trying right now to develop a low-cost, $500 heat pump water heater, which will then hopefully take up a lot of market share. So it's addressing the affordability barrier to energy efficiency through a research innovation program. So, success story.
Thank you. Thank you very much. Well, I think we are ending this first session now. Thank you very much, Peter, Hans, and Kevin for the presentation.